And now in this lecture we find out they have the green shape. In the drawing we have a semicircle, PQ equals to 10 units in its length. That is to say the diameter PQ equals to 10, therefore the radius must be equal to 5. And we have the big square ABCD and the small square MECF. And our task is to find out the area of this green shape. So first of all, we define the center of this semicircle. This point is point O. The diameter PQ equals to 10, therefore the radius of this semicircle must be equal to 10 over 2, that is 5. Okay, so we join points O and A together by a straight line. Point O is the center of the semicircle. Point A is the point of the semicircle itself. Therefore, OA is the radius of this semicircle that is equal to 5 units in its length. This is angle ABC. That is 1 out of 4 angles of this square ABCD, and therefore it must be equal to 90 degrees in its size. Likewise, this is angle EFC. It is 1 out of 4 angles of this square MEFC, therefore it must be a right angle. In the next step, we join points O and E together by a straight line. Point O is the center of the semicircle, point E is the point of the semicircle itself, therefore OE is the radius of this semicircle. This is equal to 5 units in its length. OE equals to 5. So, by doing all those constructions, we can then here two right angles. The right angle ABO and the right angle OFE. So in the next step, we will implement the Pythagoras theorem on those both right angles. According to the Pythagoras theorem, in any right angle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. We define side AB of square ABCD as A. That is to say, side AB equals to A units in its length according to our definition. We define side EF of this square MEFC as B. CF must be also equal to B because all the sides of a square are equal to each other in their lengths. We define line segment OC, the length of line segment OC is X. Each side of this square ABCD each side of this square ABCD is equal to A units in its length. So BC equals to A, BC equals to A, OC equals to X, therefore this missing line segment BO must be equal to A minus X. So in the next step, we implement the Pythagoras theorem on this right angle ABO. So on commit triangle ABO in the new page, and we implement on it the Pythagoras theorem. Here by PT is evaluation for Pythagoras theorem. So actually, this is the right angle ABO that the coach from those are going. According to the Pythagoras theorem, in this right angle ABO, AO squared, that is the square of the hypotenuse, equals to AB squared plus BO squared. So I write it down. AO squared, that is the square of the hypotenuse, is equal to AB squared plus BO squared. AO is 5, therefore AO squared is 5 squared, that is 25. And it is equal to AB squared. AB is 8, therefore AB squared is 8 squared plus BO squared. BO equals to A minus X, therefore BO squared equals to A minus X squared. So according to equation 1, we should find out that 25 equals to A squared plus A minus X squared. In the next step, we implement the Pythagoras theorem on this right angle, triangle OEF. So I copy this right angle OEF in the new page, and we will implement on it the Pythagoras theorem. Here by PT is evaluation for Pythagoras theorem. Side EF of the right angle OEF equals to B units in its length. Side OF equals to X plus B units in its length. And the length of the hypotenuse EO is equal to 5 units. So okay. This is the right angle OEF, this is the coefficient of the original drawing. This right angle OEF, OE squared, that is the square of the hypotenuse, equals to EF squared plus FO squared. So I write it down. OE squared, that is the square of the hypotenuse, is equal to EF squared plus OF squared. OE is 5, therefore OE squared is 5 squared, that is 25. And it's equal to EF squared. EF is B, therefore EF squared is V squared plus OF squared. OF equals to X plus B, therefore OF squared equals to X plus B squared. So in total, according to equation 2, we found out that 25 equals to B squared plus X plus B squared. So we have here two equations. On the left side of those two equations we have 25. So we get equation number 3 that says that 25 according to equation 1 must be equal to 25 according to equation 2. Okay, again we get equation 3 that says that 25 according to equation 1 must be equal to 25 according to equation 2. So 25 according to equation 1 is equal to A squared plus a minus x squared and it must be equal to 25 according to equation 2. 25 according to equation 2 equals to b squared plus x plus b squared. So here we will open the brackets on both sides of this equation, equation 3, and we get that according to equation 3, a squared plus a minus x squared. A minus x squared equals to a squared plus x squared minus 2 times a times x. And this is equals to b squared plus x plus b squared. X plus b squared equals to x squared plus b squared plus 2 times x times b. So here we have x squared on both sides of the equation, so x squared gets cancelled. So in this side of the equation 3 we have a squared plus a squared, that is 2a squared, minus 2ax equals to b squared plus b squared is 2b squared plus 2xb. So here we have 2ax in this equation 3, and we get that according to equation 3, 2a squared equals to 2b squared plus 2ax here it is plus 2xb. Here we subtract 2b squared from this equation, and you get that according to equation 3, two a squared minus 2b squared equals to 2ax plus 2xb. So here we divide this equation 3 by 2, and we get that according to equation 3, a squared minus b squared equals to ax plus xb. And again, according to equation 3, we should follow that a squared minus b squared equals to ax plus xb. So here we take a as a common factor from those two expressions. So inside the brackets we take x as a common factor from those two expressions. So inside the brackets we left only with a plus b, and it is equals to a squared minus b squared. A squared minus b squared equals to a plus b times a minus b. So in total, we found out that a plus b times a minus b equals to x times a plus b. Because of the fact that a and b are lengths, there must be a positive number and when you add two positive numbers to each other, the result must be a positive number. That is to say, a plus b can never be equal to 0, and therefore we can divide this equation 3 by a plus b. And you get that according to equation 3, a plus b times a minus b over a plus b equals to a minus b, and it is equals to x times ab, x times a plus b over ab equals to x. So in total, according to equation 3, if we found out that a minus b equals to x, so here we subtract from this equation x and we will add b simultaneously, and we get that according to equation 3, a minus x equals to b. So we have two equations here. According to the first equation, a minus b equals to x, and according to the second equation, a minus x equals to b. According to equation 1, we found out that that a square plus a minus x square equals to 25. So I did know. According to equation 1, we already found out that a square plus a minus x square equals to 25. But according to this equation, a minus x equals to b. So we can substitute a minus x in this expression by b. If a minus x equals to b, it means that a minus x square must be equal to b square. So we substitute this expression a minus x square by b square. So in total we get that according to equation 1, a square plus b square equals to 25. And again, according to equation 1, if you found out that a square plus b square equals to 25. Our task is to find out the area of this green shape. So what is the area of the green shape? The area of the green shape equals to the area of the semicircle minus the area of the big square ABCD minus the area of the small square MECF. And again, if you found out that the area of the green shape equals to the area of the semicircle minus the area of the big square minus the area of the small square. We know that the radius of this semicircle r equals to 5. Therefore, the area of this semicircle must be equal to pi r square over 2. R is 5, so it is 25 pi over 2. The area of the semicircle equals to 25 pi over 2 minus the area of the big square. The big square, one side of this big square equals to a, therefore the area must be equal to a square. The area of the big square equals to a square, so it is minus a square, minus the area of this small square, MEFC. One side of this square MEFC equals to b with itself, therefore the area of this square must be equal to b square. So in total, we have found out that the area of the green shape equals to 25 pi over 2 minus a square minus b square. So the area of the semicircle equals to the area of the green shape equals to 25 pi over 2. So here we take minus 1 as a common factor from those two expressions. Inside the brackets we have a square plus b square. So in total, we have found out that the area of the green shape equals to the area of the semicircle, that is 25 pi over 2 minus a square plus b square. But we already found out that a square plus b square equals to 25. Therefore, we can substitute a square plus b square here by 25. So in total, we found out that the area of the green shape equals to 25 pi over 2 and minus a square plus b square, that is 25. So in total, we found out that the area of the green shape equals to 25 pi over 2 minus 25 square units in its length, or in terms of numbers, it is equals to 14.27 square units. So if we together we found out that the area of the green shape equals to either 25 pi over 2 minus 25 square root. So in terms of numbers, the area of this green shape equals to 14.27 square roots in its size. So we finished to answer the question. So in the next step, I'll summarize the lecture. Our task in this question is to find out the area of this green shape. In the drawing, we have a semicircle. We know that the diameter PQ of this semicircle equals to 10 units inside, therefore the radius must be equal to 5. Inside this semicircle, we have the big square ABCD and the small square MEFC. Our task is to find out the area of this green shape. So we define the center of this semicircle, this point is O. Again, the diameter PQ is 5, therefore the radius OA is 5. The radius OE is also 5. We know that those two angles, they are both right angles because of the fact that triangle ABC, the square ABCD, all of the angles inside square ABCD are right angles. Likewise, all of the angles in this small square MEFC are also right angles. So this angle is right angle. So by doing all those constructions, we created two right triangles, triangle ABO and the right triangle, triangle EOF. So in the next step, we implemented, we define one side of square ABCD as A. We define one side of the small square MEFC as B. We define this line segment OC as X. BC is A. So BC, that is A, minus OC, that is X, equals to BO. EO equals to BC minus OC. So BO equals to OC, that is A, minus BO equals to BC, that is A, minus OC, that is X. So in total, BO equals to A minus X. And in the right triangle EFO, side OF equals to X plus A, side EF equals to B, and the opposite EO equals to 5 on both right triangles. According to the Pythagoras theorem, in any right triangle, the square of the opposite equals to the sum of the squares of the perpendiculars. So actually, this is the right triangle ABO, that is correct from the original drawing. According to the Pythagoras theorem, in this right triangle ABO, AO squared, that is the square of the hypotenuse, must be equal to AB squared plus BO squared. AO is 5, therefore AO squared is 5 squared, that is 25, and it is equal to AB squared. AB is A, therefore AB squared is A squared, plus BO squared. BO is A minus X, therefore BO squared is A minus X squared. So in total, according to equation 1, we found out that 25 equals to A squared plus A minus A squared. Here, we implemented the Pythagoras theorem on this right triangle, EOF. According to the Pythagoras theorem, EO squared, that is the square of the opposite, equals to EF squared plus FO squared. EO is 5, therefore EO squared is 5 squared, that is 25, and it is equals to EF squared. EF is B, therefore EF squared is B squared, plus OF squared. OF is X plus B, therefore OF squared equals to X plus B squared. So in total, according to equation 2, we have found out that 25 equals to B squared plus X plus B squared. In the next step, we can do the equation 3 that says that on both sides of this equation, we have 25. So we can do the equation 3 that says that 25 according to equation 2 must be equal to 25 according to equation 1. Again, we can do the equation 3 that says that 25 according to equation 1 must be equal to 25 according to equation 2. 25 according to equation 1 equals to A squared plus A minus X squared, and 25 according to equation 2 equals to B squared plus X plus B squared. Here we open the brackets on both sides of this equation and finally found out that A squared plus A minus X squared. A minus X squared equals to A squared plus x squared minus 2 times a times x, and it is equal to b squared plus x plus b squared. So it is b squared plus x plus b squared. X plus b squared equals to x squared plus b squared plus 2 times x times b. So here we have x squared on both sides of the equation, so x squared will get cancelled. In this side of equation 3, we have a squared plus a squared, that is 2a squared, minus 2ax. While on the other side of this equation 3, we have b squared plus b squared, that is 2b squared, plus 2xa. So here we added 2ax to this equation, and finally found out that 2a squared equals to 2b squared plus 2ax plus 2xb. So here we subtracted 2b squared from this equation, equation 3, and found out that 2a squared plus 2b squared equals to 2xa plus 2xb. Here we divided this equation 3 by 2, and finally found out that according to equation 3, a squared minus b squared equals to ax plus xb. A squared minus b squared equals to a plus b times a minus b. Here we took x as a common factor from those two expressions, so inside the brackets we left with a plus b. So this expression in total equals to x times a plus b. A and b are lengths, and therefore there must be a positive number, they can never be equal to 0. Therefore, we can divide this equation 3 by a plus b. So a plus b times a minus b over a plus b equals to a minus b, and here we have x times a plus b over a plus b is x. So in total we found out that x equals to a minus b. So here we subtracted x and we added b to this equation simultaneously, and finally found out that a minus x equals to b. Okay, so we have two equations, a minus b equals to x and a minus x equals to b. According to equation 1, we have already found out that a squared plus a minus x squared equals to 25. A minus x equals to b. So we can substitute a minus x in this expression by b. A minus x equals to b, therefore a minus x squared minus b equal to b squared. So in total, according to equation 1, we actually found out that a squared plus b squared equals to 25. Our task is to find out the area of this green shape. So what is the area of this green shape? The area of the green shape equals to the area of the big semicircle minus the area of the big square minus the area of the small square. Okay, again, the area of this green shape equals to the area of the big semicircle minus the area of the big square minus the area of the small square. The area of the big semicircle equals to pi r square over 2. R is 5, therefore it is 25 pi over 2. The area of the big square equals to a square, because one side of this square is a. Therefore, the area must be equal to a square. So it is 25 pi over 2 minus the area of the big square, that is a square, minus the area of this small square. One side of this small square equals to b, therefore the area must be equal to b square. So the area of the small circle equals to b square, so it is minus b square. So in total, we found out that the area of the green shape equals to 25 pi over 2 minus a square minus b square. So it is 25 pi over 2. Here we took 1 as a common factor for those two expressions, so inside the brackets we left only with a square plus b square. So in total, we found out that the area of the green shape equals to 25 pi over 2 minus a square plus b square. But we already found out that according to equation 1, a square plus b square equals to 25. Therefore, we can substitute a square plus b square here by 25. So in total, we found out that the area of the green shape, that is the area that we are looking for in this equation, is equals to either 25 pi over 2 minus 25 square root. So in terms of numbers, the area of this green shape is equal to 14.27 square root in its size. Okay, again, the area of this green shape equals to either 25 pi over 2 minus 25, or in terms of numbers, the area of this green shape equals to 14.27 square units in its size. Okay, thank you very much.